For over a century, the assumption that our water is clean has been a cornerstone of urban life. Massive sanitation plants and rigorous chemical treatments effectively ended the era of the great waterborne epidemics. This system has earned our total trust. We rely on the safety of every tap, fountain, and public pool, believing that municipal treatment has rendered the water completely sterile. But recent scientific findings have identified a specialized group of organisms thriving deep within these treated systems. They are surviving standard chemical defenses that were previously thought to be absolute. Our reliance on chlorine and temperature controls has worked so well for so long that it has masked a growing biological vulnerability in our public health network. These organisms are free-living amoebae. While common in lakes and soil, these microbes have successfully adapted to the unique environment of modern city plumbing. They are built to survive. Unlike most bacteria, these amoebas can withstand high doses of chlorine and survive at temperatures that would typically kill off microscopic life. The most infamous species is Naegleria fowleri, the brain-eating amoeba. It enters the body through the nose during water activities and causes an infection that is nearly always fatal. While these lethal brain infections are the most visible threat, the broader concern is how these organisms are quietly altering the entire microscopic environment of our water pipes. The primary danger of these amoebas is their role as biological shields for other, even more dangerous pathogens. When amoeba encounter harmful bacteria, they engulf them, providing a protected internal environment. As chlorine washes over the system, the amoeba's outer membrane hardens into a physical barrier. Sheltered from chemicals, the trapped bacteria survive and multiply, persisting long after they would have been destroyed. This protected space also encourages different microbes to interact and share genetic material, which can lead to the development of new antibiotic-resistant strains. Through this mechanism, amoebae have effectively turned our water distribution pipes into highly resilient mobile incubators for disease. This biological threat is finding a perfect partner in the physical decay of our city infrastructure. Aging pipes filled with rust and mineral scaling provide the ideal terrain. These rough surfaces offer stable anchoring points for amoebae to form permanent colonies. Our safety standards focus on the water as it leaves the treatment point, but that data tells us very little about the quality of the water after it has traveled through miles of compromised underground piping. Our deteriorating 20th century physical grid has now become a permanent sanctuary for the pathogens of the 21st century. A powerful environmental catalyst is now accelerating this spread, a warming global climate. Free-living amoebae are heat-loving organisms. As average water temperatures rise, their populations grow larger, and they become more biologically active. We are watching thermal zones expand. Regions that were once too cold for these amoebae to survive are warming up, allowing these pathogens to establish themselves in formerly safe northern latitudes. This heat isn't just in the air, it is warming our urban water storage. Unshaded reservoirs are absorbing solar energy, raising the temperature of the water before it ever enters our pipes. Global warming is turning deteriorating municipal water grids into a massive, interconnected breeding ground for these microbes. To address this, scientists are calling for a One Health strategy. This requires a unified response that bridges the gap between environmental monitoring, clinical medicine, and civil engineering. This means moving toward real-time microbial surveillance and the adoption of advanced physical filtration systems that don't rely on chemical reactions alone to clean our water. Relying solely on chlorine is no longer a viable defense against organisms that have evolved to withstand it. The microscopic world has successfully adapted to our traditional barriers. Our future health now depends on our ability to rebuild the way we interact with our most vital resource.